And our next presenter is Dr. Angela SOUTHEY. She's graduated from the Department of Medicine and Therapeutics in UCD, and with a PhD in lung fibrosis, and then moved to Japan for 2 years to complete a postdoctorate study on unclerative colitis. Upon returning to Ireland, she worked as a postdoctoral researcher in the Veterinary College, Dublin, investigating the feasibility of vaccinating badgers against tuberculosis to be reduced the spread in cattle. She then went to engage with her expertise in virology, first at the Irish Equine Centre, and then with Biopharma, and finally at Abbott Diagnostics.
Thank you very much. Good afternoon, everybody. The title of my talk is Independent Validation of Products which Improve Indoor Air Quality. This is just a general overview of the slides. Air cleaning technologies play a crucial role in improving indoor air quality, making it essential to verify their effectiveness and safety. This study evaluates the performance of 2 in-duct air cleaning devices, a UV-based device and an electrostatic device, using established standards to ensure accuracy and reliability. In our facility, we have a number of environmental test chambers, including a 28.5 cubic metre chamber with an ASHRAE style 52.2 test duct wrapped around the chamber, so the supply air and exhaust air can be circulated around into the chamber. We introduced challenge particulates upstream of the device under test, whether that's the electrostatic device or the UV device, and then we monitored the impact of these devices downstream, both in the test duct and in the chamber. This is just a short layout of the test duct, or showing just a segment of the test duct, where you have the fan upstream, the particulate entry point, sampling ports, sampling the particulate, and then we have the device under test here, and then the downstream sampling ports, and then also sampling ports were located in the chamber as well, so we can monitor the effect of the device at 2 locations, both in the duct and in the chamber. For the UV-based system, we used a MS2 bacteriophage challenge. MS2 bacteriophage is commonly used as a surrogate for other infectious viruses, including the SARS-CoV coronavirus. It has similar aerosol characteristics when it's airborne to these viruses, although it's a lot smaller. It's only 30 nanometers, the particles are only 30 nanometers in size approximately, whereas the SARS-CoV virus is 120 nanometers. So the point of using that was to say if the device is effective at removing smaller particles, it would also thereby be effective at removing larger viruses such as the coronavirus. Triple air samples were collected both upstream and downstream of the device. This picture here just shows the UV-based system installed in the duct cross-section of it. The viral particles for MS2 were introduced, and then the sampling was conducted in a single pass method. The viral particles were quantified using the plaque assay, and they were quantified in plaque forming units per cubic metre. The average values were then taken in a test setup with the device, and then also in a test setup without the UV device installed. Just the results show, just going to the graph, that without the device we were getting up to 8.5 plaque forming units per metre cubed of the virus, and then with the device installed there was a 2 log reduction of the MS2 bacteriophage both in the upstream and both in the downstream location, which is in the duct, and also in the downstream location in the chamber. So there was a similar reduction effect in both locations. So in conclusion, for the UV device, there was a 2-log reduction in the duct and the adjoining chamber. This resulted in an overall single-pass reduction of about 99.1%. So this shows that the UV-based device is very effective at removing infectious aerosols. So just moving on to the electrostatic device. The electrostatic device doesn't have a filter. It has charged panels which can be positive or negatively charged. This is installed in the duct strips. The allergen test dust, we make our own allergen test dust. It contains dust mite allergen, WP1, cat allergen or cat dander, FeLD1, and Timothy grass pollen. The ATD was introduced upstream of the device in the test rig, in the ASHRAE style test rig. As you can see in the picture here. The dust was introduced sequentially, and then there was followed by room disturbance, which was turning on the fan, 3 fans in the chamber. This just shows the particulate counts per meter cubed, the total airborne particulates. You can see in the control run without the device installed, which is the blue line, the airborne particles remained airborne throughout the test, whereas in the test run with the dust introduced, you can see there's a peak as the dust is introduced, but then as the electrostatic device starts trapping the particles, there's almost a 99% reduction of the airborne particulates. And then when there's a room disturbance, which is switching the fan on for 10 minutes, the fan's on, you can see there's a small increase and there's some residual particles, but generally after each introduction it just shows that the electrostatic device is capable of removing a significant load of airborne particulates. We introduced 12 grams of dust on each occasion, which would mimic the use of a HVAC system, I suppose, in a house over several months. And then the next day there was also a room disturbance done the next morning in the chamber, and you can see that it had some small increase, but in the control rooms without the device there is still a significant amount of airborne particulates. And then this is the airborne allergen data. I'll just quickly run through. So there was a percent reduction of over 90% in most cases for the allergens. The dust mite allergens being the largest particle size, and also the Timothy grass pollen is also about 20 microns. Whereas the FeLD1, it was also effective against smaller particles. The FeLD1 tends to be only between 2 and 3 microns in size, but we're still getting a very good reduction of 99 or 98 or 99% for the cat allergen. So overall, the total airborne particle counts increased from background levels to up to greater than 1 by 10 to the 8 particles per cubic meter during the 3 sequential introductions of the dust. And then this rapidly decayed due to removal by the electrostatic device. Subsequent room disturbances demonstrated limitable particle counts increases. By comparison, in the absence of the device, airborne particle counts remain below, just below 1 by 10 to the 9 particles per cubic meter. So the percent allergen reduction was about 90% for the airborne allergens. Overall conclusions then, the demonstration of the efficacy of and safety of an air cleaning technologies is paramount for mitigating the spread of infectious airborne viruses and pollutants. Testing was conducted in an indoor air quality laboratory with advanced equipment and expertise, which provides third-party assurance of the technology's performance and safety. Furthermore, collaboration with an established third-party lab experienced in bioaerosol testing, such as viruses, bacteria, allergen, and mold, enables the generation of reliable data to support claim verification and for air cleaning technology manufacturers. Thank you very much.